Welcome to this new video. In this video, I'm going to discuss the demographic transition model. The demographic transition model attempts to describe and predict how population will change over time as it changes from an agrarian society to an industrial and post-industrial society. Some of the key terms in the demographic transition model, that is DTM. So we have crude birth rate, crude death rate, natural increase rate, total fertility rate, infant mortality rate, and life expectancy. Crude birth rate means total number of live births in a year for every 1000 people alive in the society. Crude death rate means the total number of deaths in a year for every 1000 people who are living in the society. Natural increase rate is the percentage growth of a population in a year computed as the crude birth rate minus the crude death rate. Total fertility rate is the average number of children a woman will have throughout her childbearing age. Infant mortality rate is the total number of deaths in a year among infants under 1 year of age for every 1000 live births in a society. Life expectancy means the average number of years an individual can be expected to live given current social, economic, and medical condition. Life expectancy at birth is the average number of years a newborn infant can expect to live. This is the demographic transition in which there are 4 stages here. On the left hand side we show crude birth and death rates per thousand population, and on the right hand side we have natural increase rate. We will discuss this in detail in coming slides. This is the stage 1 of the demographic transition. Here high fluctuating crude birth rate and crude death rate that is near 0, and the natural increase rate is about 0.05%, and the population is very low. If you look at this J-shaped curve of the world population, one can notice that human society has been in stage 1 of the demographic transition for most of human history. This is crude birth rate per 1000 persons that you can see throughout the globe. Here we can see in another diagram when the stage 2 of the demographic transition started. Now it is easy to see when the world entered stage 2, and that was around the year 1800 with the Industrial Revolution. So it means that the world entered the second stage of demographic transition after the Industrial Revolution. Here we have stage 2, that is crude death rate falls and crude birth rate remains high, and the natural increase rate is increasing, and there is rapid population growth. Then we have stage 3, where crude death rates decline slowly. Crude death rate declines slows, crude birth rates falls, natural increase rate also falls, population growth is slow. And at stage 4 there is low CDR and CBR, and the natural increase rate is also low but stable, but now there is large population. This is the example of 5 different countries which shows the demographic transition in these 5 countries, that is Germany, Sweden, Chile, Mauritius, and China, and you can follow the pattern of demographic transition in these 5 countries. This is once again the total world population, and there are 2 different regions, that is the developed regions and the developing regions. The developing regions basically means the LDCs, that is less developed countries, and they move into stage 3 and 4, and total world population will level off at around 12 billion sometime around the year 2100. MDCs, which stands for most or more developed countries, they have already moved into stage 3 and 4. This is again a demographic transition model, and here in stage 1, birth and death rates are both high, leading to a low but stable population, and you can see this is a stable population in stage 1. There is high fluctuation. UK pre 1760 industrial revolution and remote tribal groups. Here we can discuss stage 2 of the demographic transition. Birth remain high, but now death rates start to fall dramatically, leading to a rising population. So this is the second stage. And the example include UK pre 1760 up to 1880. Peru, Sri Lanka, Kenya are presently in this stage. Here we discuss stage 3. Birth rates starts to fall now, and death rates continue to fall, causing the population to continue to rise, but less quickly now as the gap between births and death is closing. So this is how population grows in this stage. And examples include China, Cuba, Australia presently, and UK between 1880 and 1940. Here we are discussing stage 4 of the demographic transition model. Birth and death rates are now both low, causing the population to be more stable but high. And examples include Canada, USA, Japan, and UK in post 1940. This is once again demographic transition and a little bit more detail. Natural increase is low because although there are a lot of births, the similarly high number of deaths effectively cancels them out, leaving a low but stable population. This is stage 2. Here in this diagram you will see stage 3 that we have already discussed, and in this figure we are going to explain stage 4, where there is natural increase of population is again low, and births and deaths virtually cancel each other out, but now the population is very high. And this is the overall demographic transition model showing all the 5 stages. So there is a more detail in stage 1, which is high stationary, and this is stage 2, early expanding, and these are the examples of countries, and it shows birth rate, death rates, natural increase, reason for changes in birth rate, and reason for changes in death rates. Then we have stage 3, stage 4, and stage 5. My dear followers and subscribers, I hope you have correctly understood the demographic transition model. If you have any question, you can write your question in comments. I'll try my level best to answer your queries. If you haven't yet subscribed to the channel, kindly subscribe to the channel and click on the bell icon so that you can get notifications about my other videos that I'll upload for you. Thanks.